Hi, Ms. Jang.
Hi, Ms. Farrell, and today we're going to be learning about how to solve systems of equations by elimination. So by the end of the lesson, students will be able to find the x and y values that satisfy the two equations by using elimination.
And I'll walk through the steps of how we use elimination, and Ms. Farrell will do an example on the board after. So I'm going to walk through the steps that we're going to take to solve the system of equations using elimination. So for our first step, we're going to pick a variable, and the example that Ms. Farrell is going to go over right after this is 3x plus 7y equals 24, and 6x plus 3y equals 15. So we're going to pick either x or y, and then the second step is we're going to multiply the coefficient to eliminate the chosen variable. So she will pick either x or y, and here we have 3x plus 7y equals 24, and this is 6x plus 3y equals 15. We can either multiply the top equation by 2 so that we can cancel out the 6's, or multiply the top by 3 and the bottom by 7 to cancel out the y's. And then after we multiply the coefficients, we're going to subtract one equation from the other. So if we choose x, we're going to subtract the top equation from the bottom one, and then solve for the variable. So after we solve for the variable, we're going to substitute the value back in and solve for the eliminated variable. And then once we've gotten our x and y value, we're going to check our work and substitute both values back into the equations check. And then now Ms. Farrell is going to walk you through this example.
Now that we know the steps for solving systems of equations, let's look at an example. Let's say, for instance, you have two equations. One, 3x plus 7y equals 24, and another, 6x plus 3y equals 15. To solve this system of equations by elimination, we're going to first identify which variables we want to eliminate. So we're going to multiply this entire top equation by -2, because -2 times 3 is going to be -6, and we want to eliminate this 6x from the 6x on -6x on the top. So using the distributive property, we're going to create a new equation for the top. So this is going to be -6x minus 14y equals -48. We're going to keep this exact same equation on the bottom. We're essentially just going to multiply it by 1. So it's going to be 6x plus 3y equals 15. So now we can see when we add our two equations together, the -6x and the 6x here eliminate. So we're going to continue to find the rest of the equation. So -14y plus 3y is -11y, and -48 plus 15 is going to be -33. Now to isolate our variable, we're going to divide by a -11 on both sides and get y to be 3. So now that we have one of our values of y, we can find x by plugging 3 into either of these two equations to find x. So I'm going to use the first equation. You can use whichever one you want. So I'm going to say 3x plus 7, and now we know y is 3, so we can plug it in. 3 equals 24. Okay, so now we can solve for x by simplifying this equation. So 3x plus 21 equals 24. Continuing to isolate our variable, we can subtract by 21 on both sides. We get 3. So now that we can see when we're isolating our variable, we get 3x equals 3. And we get divided by 3, x to equal 1. So now we have x to equal 1 and y to equal 3. So we can check our work by plugging these two values back into either one of our original equations to check our work. So we have 3 times, now we know x is 1, so we can plug that in, plus 7, we know 3 is y, equals 24. Let's see if this satisfies this part of the equation. So we have 3 plus 21 equals 24. And now we have 24 equals 24. So we can conclude that the x and y coordinates for that satisfies these two equations is y equals 3, x equals 1, and y equals 3.